Okay, so this is the Junior Cycle Higher Level Maths Paper 2 for 2018, and it's question 11 and 12. So to start here, we're going to do question 11. F is an angle in a right angle triangle, and the cosine of f is 6 over 11. By drawing a diagram of a right angle triangle, find a value of sine f. Give your answer in surd form. Okay, so the first thing we're going to do here is just draw a right angle triangle. And you can use a ruler here. I'm doing it freehand, but we have the cosine of f, so we'll call this f here, and we're told that the cosine of f is 6 over 11. So the cos of f is going to be the adjacent over the hypotenuse, so the adjacent is here, so that's the 6, and the 11 goes here. So there's our diagram. Now we've got to find the sine of f. Now the sine of f is the opposite over the hypotenuse, so we have to work out what this is here. Let's call it x. So we can just use Pythagoras' theorem here. So we got 6 squared plus x squared is going to give us 11 squared. So this here will give us 36 plus x squared is equal to 121. That will give me x squared is equal to 85. And that finally will give me x then is equal to the square root of 85, which I can't really simplify any further. So it says give your answer in surd form, so I'm going to leave the square root here. So we know that x here now is going to be equal to the square root of 85. So we need the sine of f. The sine of f is what we were asked for. So that means then the sine of f is going to be opposite over hypotenuse, so that's the square root of 85 divided by 11. And that's it. That's actually it for question 11. Let's have a look at question 12. Now, the diagram below shows a Horcrux. ABC is an equilateral triangle, so this triangle here is an equilateral triangle. That means that this angle here will be 60 degrees and this angle here will be 60 degrees. We may or may not need that. And this angle up here will be 60 degrees, which means this will be 30 and this will be 30 here. We could put that in if we needed to. I don't know if we'll need it, but so that's that part anyway. Okay, so D is the midpoint of BC. So D here is the midpoint of this here. So this length here is equal to this length here. AD is perpendicular to BC. AD is perpendicular, so this line here is perpendicular to BC. The circle K touches the three sides of ABC. So we have our circle K and it touches the three sides. It's an incircle of the triangle ABC. Okay, first thing we have to do is to write the correct transformation into the box below. Be as specific as you can. Okay, so in here we got to write down this transformation. So what is it? It's ABD. ABD is the image of ACD. ACD under what? So you got to reflect ACD using axial symmetry in the line AD, and that will give me ABD. So we have this line coming down here, which is our axis, and we've got to reflect the triangle ACD in that line under axial symmetry. That will give us ABD. So it's under axial symmetry. In AD, in the line AD there. That's really it. We're just reflecting. So A is the image of A is A, the image of C will be B, and the image of D will be D. So that's it for that part. Let's see part B then. AD is 10 centimeters, so this line here is 10 centimeters. Work out the length of AB, so this length down here. Okay, so now we are going to end up using this angle here, 60 degrees. Let me just redraw ABD. So I'm going to draw ABD. So we've got a right angle triangle here We've got A here, we've got D here, and we've got B here. We know that because the triangle ABC is an equilateral triangle, we know that this is 60 degrees. We're told that AD is 10 centimeters, and we've got to work out the length of AB. Now we don't have this length here, so we can't use Pythagoras' theorem to work out AB, so we've got to use sine, cos, or tan. So we want to work out this length here, which is the hypotenuse. We have the opposite, so the opposite over the hypotenuse is actually the sine of her angle there, which is 60 degrees, which is 10 over our distance AB. So we just multiply across by AB, so you get the distance AB times the sine of 60 degrees is equal to 10 centimeters. So that will just finally give us the length AB is equal to 10 divided by the sine of 60 degrees. Now you should recognize that 60 degrees is one of these special angles, and you get the sine, cos, and tan of 60 degrees, 30 degrees, and so on in your tables. So you'll find that, and remember we have to give our answer in surd form, so that's why I'm saying this rather than decimal form. So we have 10 over, now the sine of 60 degrees, the sine of 60 degrees, if you look it up, is actually the square root of 3 over 2. Now we end up then with AB, the distance AB is, we have 10 divided by a fraction. So how do you do that? Well, you take the fraction, you turn it upside down, and you multiply. So this is what we end up with here. So this is just, let's just finish that off here. We've got the length AB is going to be equal to, that's 10 over 1, so 2 tens, 20 over square root, sorry, that should be square root 3 I should have there. Let me just redo that. This part here is actually a 3. So this is square root 3, square root 3. Okay, so that's really it. Or your calculator, if you did this, may give you something like this: 20 root 3 over 3. It's the same kind of thing, because 3 is just root 3 times root 3. In other words, 20 root 3 over root 3 times root 3. This 3 here is just square root 3 times square root 3. That'll divide by that, and we just end up with 20 root 3. Either of these answers is correct anyway. They're both in surd form, which is what we were asked. Give your answer in centimeters in surd form. So let's just put in centimeters here as well, put in the units. Okay, let's have a look at this then. The diagram below shows the triangle ABC. So I have a triangle here, it's quite big, ABC. Construct the rest of the Horcrux using the following facts. So the line AD is a perpendicular bisector of BC. So we've got to construct a perpendicular bisector of BC here, first of all. Okay, secondly then, the center of the circle K is the point of intersection of AD, so that perpendicular bisector, and the bisector of the angle B. So we've also got to construct a bisector of this angle here. We've got to bisect this angle. That will draw a line up here, it will intersect this line, and that intersection is the center of our incircle there. And is that all we have to do? Let me see. You may only use a compass and a straight edge. Show all your construction lines clearly. Okay, so I just have a little diagram here that I'll show you. It's this is our equilateral triangle, and the first thing we have to do is bisect BC. So to bisect BC, I can do that doing this here, and you can see this line here has bisected BC here. It's a perpendicular bisector, and because this is an equilateral triangle, it happens to go through A as well. It happens to be a bisector of this angle. But anyway, we were just required to bisect BC. Now the second thing we have to do is bisect this angle here. We got to bisect the angle ABC. So you got to cut that in half. So to do that, I just click here, here, and here. Now I've ended up with a bisector of this angle. I've bisected this angle. So next thing I've got to do now is draw this circle. So let's see if I can do that. Let's use this one here. So this is going to be the center of the circle. So you put the sharp bit of your compass here if you like, and then you bring your pencil out to the edge, and you will just end up drawing a circle, this in circle here, and that's what you should end up with. Now to do that in the exam, if you like, you would need to do the following. The first thing we need to do is bisect this line here, and the way you do that is you're going to take your compass, put the sharp bit here, bring your pencil up here, and you're going to draw an arc here. Now I'm doing this freehand, so you'll have to do this properly. So you put the sharp bit here again, without actually moving the compass in or out, you draw another arc here, like this. You then come down here and do the same thing, so you're going to end up with the arc down here, and you're going to end up with an arc here as well. So where these points bisect, you've got to draw a point here, draw a point here. This isn't going to be too accurate, but you end up drawing a line down through here. So you'll end up, let me do it in a different color here. So we're going to end up with a line going down through here, and this line here, not very straight, but you guys will have to use a ruler, will end up being a bisector of this line here. Okay, so the next thing you've got to do is bisect this angle. So in order to bisect this angle, you take your compass again. Let's do this in a different color again. So you're going to take your compass, put the sharp bit here, bring your pencil up here, and you're going to draw an arc here, and you're going to end up drawing an arc here. Just plot those points here, put in a point here, put in a point here. It's important in the exam that you leave these arcs here. These are your construction lines that you've got to show. So next thing you're going to do then is bring your compass up here. Don't move your compass in or out, just leave it at the same distance. Put the sharp bit here, bring your pencil out here somewhere, and you're going to end up drawing an arc here. Put the sharp bit here, draw another arc here, and what you're going to do then is mark that point, and you're going to end up drawing a line from here up through here, up through that particular point. I missed it there, but you get the idea. So you should end up with this line here, and this here will be equal to this here. It doesn't look like it here because I'm doing it freehand, but that's your bisector of this angle. Now the next thing you're going to do then is look at where these two lines bisect. By the way, your perpendicular bisector here would really need to have gone all the way up to here, because this is your line AD. Okay, so next thing you're going to do is look at this point here. So you're going to take this point here is the bisector of this line and the blue line. So this is where you're going to draw your circle from. So you take your compass, you put your, well, what you can actually do first is get a set square and just put your set square here. So you can put your set square along this line here and bring it up through this point here. And what that does is it gives you the point that you're going to actually put your pencil when you're drawing the circle. So you'll have your set square up along here like this. Okay, so you put your sharp bit of your compass here, and you put your pencil here, and you draw your circle. Now I'm not going to be able to draw this at all well, but you should end up with a circle. Now that's not a good circle, but that's what you should end up with, and that's basically your Horcrux. You've got your line down here, you've got your circle, and you have your equilateral triangle. So you should end up with this is a lot more accurate. You should end up with something like this. Okay, now I think that was all we had to do with that particular question. The diagram shows construct the rest of the Horcrux using the following facts. So we've drawn our perpendicular bisector, We've drawn our bisector of the angle at B, and we've shown all our construction lines clearly. Your construction lines will be a lot neater than this because you'll actually be using a compass and your straight edge. Okay, so that's I think it for this particular question.